Okay. I'm going to pick it up where we stopped last time, but I'm going to do a quick example for review. The example I'm going to go through, so you'll remember last time I gave you a recipe for calculating probability of error. So what I'm going to do is I'm going to introduce a new signaling scheme, and I'm going to go through the recipe to calculate the probability of error, and then I'm going to show you that the choice of threshold is important. So, the example I'm going to use is the following. So S0, the signal I use to transmit 0, is all 1. So this is like polar NRZ to NB. And S1 is now equal to all 0. So all the samples are at 0 from time 1 to NB. So this is called on-off keying. It's called on-off keying because if you transmit a 0, that's like being on. Everything is 1. And if you transmit a 1, then everything is 0, meaning off. So on or off. So what I'm going to do is I'm going to say probability of the 0 and probability of 1 are the same. This is the most common case that they're both equally probable. And I'm going to say, let's do 2 thresholds. The first threshold I'm going to say Z is 0. And the second threshold I'm going to say Z is NB over 2. So this is the threshold we've been using a lot up till now. And it works pretty well, or it seems to have worked pretty well when S1 is equal to minus S0. But let's try it again in this circumstance and see how well it does.
So Z equals to 0 is for S0. For 0?
These are the 2 signals.
Yeah. But the thresholds are made for specifically for 0 bit or 1, like 0 or 1? Or
No, you can't. The threshold is to distinguish between 0 and 1, so you can't really assign a threshold to a bit or the other bit. I'm going to do the same problem, but for 2 different thresholds. Okay, so the first thing we do in our recipe is we get the noise-free filter outputs. I didn't specify what the filter is, so let's let, since S0 of K is the same as in polar NRZ, let's let H of K be the same as in polar NRZ. And that means H is equal to S0 at K plus 1. Which is equal to this. So where H of S of K went from 1 to NB, H of K will be 1 from 0 to NB minus 1. So just everything's shifted to the left by 1. So, because I'm using the same filter as in polar NRZ, the noise-free filter output for a 0, if a 0 was sent, the noise-free filter output is S0K involved with H of K, evaluated at time NB. And because both of these are the same as in polar NRZ, the result has to be the same as in polar NRZ. Does anybody remember what that is? NB. Okay, S1 is S1 of K followed with H of K, evaluated at NB. which is, okay, S1 is always 0. So this is 0 involved with h of k. And b, can anyone tell me what that might be?
0.
0. So if a 0 is sent, the noise-free filter output is NB. If a 1 is sent, the noise-free filter output is 0. Okay, so let me write those down over here. That's 0, that's NB. That's 1 is 0. Part 2, what do I do next? Does anybody remember? Variance, noise variance. So basically, we need to do 3 things. We need to set up the Gaussian, or to set up the Gaussian, we need mean and variance. So these 2 values give us the mean. So the next stage is the variance. And I have a formula that says the variance is n0 over 2ts times the sum where I equals the sum over all I, h of I squared, which is equal to n0 over 2ts, the sum over all defined h, so that's I equals 0 and b minus 1. And what's h over that ring?
1.
It's just 1, because it's the same as S0. So that's n0 over 2ts. Sum from I equals 0 to nb minus 1 of 1, which is what?
NB.
Yeah, this is nb. So the whole thing is n0 over 2ts nb. Okay, step 3 is the probability of error. So we have mean, we have variance, and now that we've set up mean and variance, we can actually calculate the probability of error. And that is given by a formula, which is 1/2 of C. That's 0 minus Z over root 2 sigma squared times the probability of 0. So this is the probability of error given 0 plus 1/2 of C Z minus S1 over root 2 sigma squared times probability of 1. So this is the probability of error given that a 1 was sent. And this is equal to, all I have to do now, well, let me write this over here. All I have to do now is substitute. Okay, S0 is NB. Let's do the case of Z equals 0 first. If Z is 0, we have 1/2 of C. S0 is NB, Z is 0, so this numerator is NB. The denominator is 2 times N0 over 2TS NB. So what we end up with is the square root of TS NB over N0 times probability of 0, which is 1/2, so I'll replace that with 1/2 plus 1/2, again 1/2 times probability of 1 is 1/4. Of C, okay, Z is 0, S1 is 0, so the numerator is 0, so it doesn't matter what's in the denominator.